Hello, this is Material Processing Methods for Blacksmithing by Abby, Colin, and Ben. Material processing is fundamental to engineering design and manufacturing. The mechanical properties of metals such as tensile strength, hardness, ductility, and fatigue resistance are not just determined by composition, but by the processing methods used to manipulate their microstructure. Techniques like rolling, heat treatment, surface hardening, and controlled cooling allow engineers to tailor materials for specific performance criteria, balancing strength, toughness, and ductility. These processes enable production of reliable, cost-effective components for industries like automotive, aerospace, construction, and tooling, while also offering versatility for aesthetic design and specialized applications. Hot rolling is performed above the metal's recrystallization temperature, which breaks down porosity and coarse grains, producing a tougher, more ductile material. However, the surface develops an oxide scale, often requiring extra finishing like pickling or grinding, and the dimensional precision is lower due to thermal expansion. Cold rolling happens at room temperature. It produces a smooth, scale-free surface with high dimensional accuracy and strength, though it's less ductile and more expensive due to slower production and higher labor costs.
The processing methods include shot peening, which involves shooting little metal pellets at the surface of material to create compressive points on the surface, as shown on figures on the left, as well as case hardening, which involves heating material and rapidly cooling it, as shown in the figures on the right side. The phase diagram in the upper left corner demonstrates the different microstructures that exist in steel at different temperatures and different carbon concentrations. And then the bottom left showcases those different grain structures of those different microstructures. Our TTT plot demonstrates those microstructures existing at different temperatures along different time intervals. And a little chart on the bottom right helps to explain that TTT curve. The graph shows the differences between tempering, quenching, annealing, and normalizing, the temperatures each process reaches, and how quickly each process cools the material.
The carbon content of steel has various effects on ductility, strength, machinability, weldability, and cost, with high-carbon steels being the strongest and most expensive, while low-carbon steels are cheaper and more ductile, making them easier to machine. Moving on to material selection methods, the specific stiffness is a useful ratio that allows us to effectively compare materials and find relationships between stiffness and weight. Let's do an example. Given some requirements, we can calculate our material index, which is an important ratio that helps to minimize mass. With a material index of 1, we know that we need to look for a metal of some kind. Ashby charts are especially useful in determining the exact type of alloy for a specific application. Using our requirements, we can find that titanium, nickel, and steel alloys meet our goal.